All right, so we are going to do target B3, which is integration. So we've been reviewing integration last week. We're going to do the third type. And what I want to do is differential equations. So we're doing differential equations. All right, and so a differential equation looks like this. dy dx equals, so 3x over y squared, something like that. And we want to solve this differential equation. So the first thing we would need to do is we would need to get all the y's on the left and get all the x's on the right. So the first thing I would do would be multiply y squared over to the left side. And then I'd multiply the dx over to the right side. So this is where we separate, and then we're going to integrate. So we separate and integrate. So I've separated by getting the y's on the left and the x's on the right. And now we integrate both sides. So we do the antiderivative. So that would be y cubed divided by 3. And typically you put a plus c, but we're only going to put the plus c on the right side. And the antiderivative here would be 3x squared over 2. And then we would want to solve for y. So if I was solving for y, I'd probably multiply through by 3. And that would give me 9/2 x squared plus 3c, because I just multiplied everybody by 3. And then I would take the cube root. So then the answer to my problem would be the cube root of 9/2 x squared, and I can't write off the board, plus 3c. So that would be my answer. Let me write a little smaller so I can get it all on the page. So that would be y equals the cube root of 9/2 x squared plus 3c. And so that's my answer, right? So the only thing different would be if I was given a problem such as this. And let's say it's 4xy minus 3x squared y. And then they also told me y of 2 is 5. Okay? So y of 2 is 5. Whoops, not doing what I want to do. So that just means once I solve the problem, I want to get rid of c by using this. This is called an initial condition. And your initial condition is information that you'll use at the end to solve for c. All right, so first thing I want to do again is I want to get the x's on the right and the y's on the left. So notice both terms here have a y in them. So what I would do first would be I would factor out a y. All right, so I'd factor a y out of both of the terms, and then I would divide by y, and then I'll multiply the dx to the other side. So now I would integrate. So I've separated, now I would integrate. And we know 1 over y, that's the natural log of y. And so here we'd have 4x squared over 2 minus 3x cubed over 3, and then we put our plus c. All right, and typically what I would do at this point is I would go ahead and I would treat this, remember since it's ln of y, I would use these as exponents and I would raise both sides to the e. All right, and when you do that, these two cancel. So you get y equals, and remember these are the exponents on e, and whenever you add powers, it's a multiplication. All right, so then you would get e to the, this really ends up being 2x squared, and this really just ends up being minus x cubed. And then when you're adding, you're really multiplying by another e to the c. Remember when you multiply powers, you add the exponents. So really this is getting multiplied by an e to the c. And because when you multiply, we add that C onto the power. So I'm just thinking about reversing this. And so this becomes a big C. So I hope you remember this from, I'm just going a little fast, I know. So remember, subtracting your exponents is division, adding your exponents is multiplication. So I could split this plus C up into the product of another E to the C, that I would multiply this stuff times E raised to the C. Because then when you combine this together, you would add exponents. So you would add another little C on the end of this exponent. So I'm breaking it up, and then this now, E to the C, becomes this new coefficient because it's just a constant. All right, and so then you would go and use your initial condition here. When you plug in 2 for x, the answer is 5. So the answer would be 5 when I plug in 2 for x. So I'd have e to the, plugging in a 2 up here. 2 squared is 4 times 2 is 8, and then a 2 here would be 8, so it would be 8 minus 8, so that would give me 0, which e to the 0 is 1. So that means C is actually 5. It doesn't always turn out to be that way, but just this time it turned out e to the 0. If this had been e to the first, I would just divide the e to the other side, and 5 divided by e would equal my C. So just whatever turns out, you just solve for C to get your C value. So now your answer to the problem is you plug your C value back in. So my actual answer, I'll change the color here. My actual answer to the problem is going to be y equals 5 e raised to the 2x squared minus x cubed. That's my actual answer to the question, because we just solved for C and we found C was 5. So these are separate and integrate problems, and sometimes you're given an initial condition to solve for. All right, let's say I gave you a trig one, because I know that's your favorite, right? dy dx equals 1 over secant y tangent y. All right, and this one says y of 0 equals pi. So again, we would want to separate and integrate. So there's no x's over here, so I'd basically just multiply this denominator over this side. So I'd have secant y tangent y dy equals, and then the 1 would stay here, and I'd multiply the dx times that. So that's separating, getting the y's on the left, x's on the right, and then when I integrate. So now I got to think, what's the antiderivative of secant y tangent y? So whose derivative is secant x tangent x? Go back to your rules. Well, that's the derivative of secant. So this is going to be secant y, because that's what letter I'm in. I'm in terms of y's. So the derivative of secant y is going to be secant y tangent y. All right, then the antiderivative of 1 is x, and this is where I put my plus c. All right, and so now if you think about what this would be backwards, the secant of y is x plus c. So the other way to think about this is y equals the inverse secant of x plus c, right? That's the way to reverse this and solve for y, is to do the inverse secant. All right, so we're saying when x is 0, so I'm going to plug a 0 in here. When x is 0, I get y is pi. So that means the secant of pi is 0 plus c. Because when x is 0, the answer for y is pi. So we got to think on the unit circle, what is the secant of pi? So on unit circle, pi is over here. That's the -1, 0. So remember, secant is the reciprocal of cosine. So the cosine is -1. So the reciprocal of that would be -1. So -1 equals c. So then I can plug that in here. So if I change my color again to show my answer, y is going to equal the inverse secant of x minus 1, because c ends up being -1. All right. So all you're doing is separating and integrating. So you're solving for C using the initial condition. So this here's the general solution, and then our particular solution is where we've got our C value plugged in. All right, so separating and integrating. So hopefully you remember separating and integrating from last year. And so the next thing I want to talk about is just something I think is important: mental integration. Just something I think we ought to work on. All right, so this is mental integration. What I mean by that is not using U substitution, being able to look at the problem and reverse it. Because a lot of times when we get into what we're going to be doing here, when we start learning new content, a lot of the problems are going to be recognizable, and you're going to be able to do a lot of these in your head. For instance, if I gave you this problem right here, all right, I should already know this answer. All right, this quantity raised to the third power, and then it's multiplied by 6x dx. Now, what I'm noticing here when I'm looking at this problem that I'm being asked to integrate, the derivative of the inside here is 6x, which is right here. So if you see your chain rule already applied to the problem or already in the problem, then you know the answer is just up one degree, but it's also it needs to be divided by that power. So we're taking this same problem, and when you take this derivative, you multiply the 3 to the front, or actually the next power up. You would have multiplied that power to the front, dropped a degree, and then do the chain rule. Well, my chain rule is already in here, all right? So all I have to worry about is reversing the power rule. So the answer to this problem is going to be 3x squared plus 7 raised to the fourth power divided by 4 plus c, because my chain is already in this integral. Okay, so think about taking the derivative of this. I would multiply the 4 to the front, so that would cancel this 4 on the bottom. Then you would drop a degree, which would give you a 3, and then you would chain on the derivative of the inside, which is the 6x. So these kind of problems are really, if you can recognize your power rule is in there, or your chain rule is in there, then you're basically just reversing the power rule on this quantity. All right. So it's nice if the problem's already in there. So for instance, if you took a problem here like this, 5x cubed minus 1 squared, and then 45x squared dx. All right, so now if I'm looking at this one, I should be able to figure out what the answer is already. What's my chain on the inside here? Well, my chain on the inside would be 15x squared. Well, this is 45x squared. 15x squared is what my chain is, okay? Which means I have 3 times that. And if I have 3 times that, well, that's what the power would be originally, all right? So all this is going to be is 5x cubed minus 1 to the third plus c, okay? Now, let's check it out and see. If I were to do the derivative of this, I would multiply 3 to the front. Then I would write all this over and drop a degree. So there'd give me this to the second power. And then I would do my chain rule, which is my 15x squared, which would have to be multiplied by the 3 in the front, which gives me the 45. So the power of 3 from this power rule, taking your derivative, is already in this problem. And so this is my answer. So, and this is what I'm doing is I'm not doing u substitution, because typically when you would do these integral problems here, you would let u be the 5x cubed minus 1, and then you would do your u substitution and that kind of stuff. So what I'm trying to get you to think and do to where you can do some of these BC problems a little quicker is to see if you can do the integral without the u substitution. If you can figure out that your derivative is already in the problem. This only works, of course, when the derivative's up, part of the derivative is in the problem already. But these are the things I want us to look for, is look to see that your chain rule is already in the problem. And so then you're just looking at a power rule situation for this embedded quantity, 5x cubed minus 1. So I know the antiderivative is going to be raised to the third power. So it's going to have a 3 and a chain rule, which is going to make 45x squared. And there that is right there. All right, I'm just trying to get you to see if you can recognize these. All right, here's another popular one to recognize, 8 over x dx. All right, I know that's the same thing as 8 times the integral of 1 over x dx. So I'll be able to do that one real quick. That's 8 times ln of x plus c. Boom, done. All right, so just be able to recognize those kind of things. Here's another one, 5e the x dx. Well, that's just 5 times e to the x, and we know e to the x is his own derivatives and his own integral. So there's our answer. Boom, done. All right, what about one like this? E to the 3x squared times 6x. Whoops, I didn't put my little dx in there. All righty, so what's this one give us? All right, so notice, you know the derivative of e is his own derivative, And then you have to chain on the derivative of the exponent, which is right here. So that means that's e to the 3x squared plus c. Because if I take the derivative of this, he's his own derivative, and then you chain on your exponent, and there it is. So the integral of that is pretty easy because the derivative is already in there. So it's just watching out for these kind of things that you can do. All right, let's change the color. What if I had one like this? 2x plus 1 over x squared plus x dx. What if I had that? All right, just recognizing that, well, I notice in my denominator here, the derivative of this denominator is 2x plus 1, which is in the numerator. So that means that answer is natural log of the absolute value of x squared plus x plus c. There we go, done. Because remember, the derivative of natural log is the derivative of the function over the function itself. So just trying to recognize things like this and being able to instead of having to take the time to do all of that substitution, it's very helpful if we can do some of this quick stuff and do some of these in our heads. Of course, it only works when they work out nice. I mean, that's not going to happen all the time, but just being able to recognize that sometimes this is going to happen and we can do these quicker. All right, so take, for instance, this one. The derivative of my denominator here is going to be 6x squared. So let me change the color because I'm thinking about this. The derivative down here is 6x squared minus 3. That's the derivative of this denominator. Well, I notice up here I have 24x squared minus 12. Well, that's just this times 4. All right, so that means I have 4 times as much as I need. So my answer is 4 times the natural log of the absolute value of 2x cubed minus 3x plus c. Because when you take the derivative of this, you're going to get 6x squared minus 3 divided by this function, and then we're going to multiply it by 4, which is the 24x squared minus 12. So you just had an extra factor of 4 in there, so that means your answer is going to have an extra factor of 4. All right, and then, of course, your favorite trig functions. So what about 9 secant squared x dx? That's going back to the old school, easy ones. So whose derivative is secant squared? We should just be able to do that very quickly. That's going to be 9 tangent x plus c, because the derivative of tan is secant squared. So I just wanted you to think about some mental math problems without doing use substitution, just being able to try to go through and figure out the antiderivative, the general solution, without going through all of that algebra steps. Recognize derivatives and see if, so there's a whole practice page of this that I want you to do just to kind of get your brain ready for what we're going to be learning when we start learning some of these BC topics in the future.